organic acids. So let's just go back to our table R, because that's our reference point, and we want to lean on this. So organic acids, and take a look. The carbon that has the functional group, it has a double bonded oxygen and a hydroxyl. So the double bonded oxygen and the hydroxyl group are attached to the same carbon. And we typically see this on the rightmost terminal carbon. And take a look at the name. Our example name is propanoic acid, and so that gives us a lot of clues of what our name should look like. And I always tell students that ic is a suffix for acids, whether it's an organic acid or not. But when it's an organic acid, it's oic, and I'm like, because think, it means it's an organic acid. So just little things that you can think about. So let's go through a couple of examples here. So here we go. So our first example, I'm going to move right here. So we're going to start off with a 2-carbon parent chain. And bond fulfillment comes from the 6 hydrogens. And we have drawn this quite a bit. So 2-carbon parent chain, prefix is eth. Those carbons are attached to each other with a single bond. So this would be the hydrocarbon ethane. And so what is going to happen here is that we are going to do a substitution to this molecule, and we are going to add an oxygen to the structure and an OH. So this oxygen is going to come in and join this, and it's going to cause these 2 hydrogens to be replaced or substituted out. And the OH also wants to come into the exact same carbon, and it kicks the other hydrogen off. So what we end up with is we still have our 2-carbon parent chain. The first carbon keeps all 3 of its hydrogens. Our terminal right carbon, 2 of the hydrogens are replaced with that double bonded oxygen, and the third and final hydrogen is replaced with that hydroxyl group. And remember, the hydroxyl, you have to show the carbon bonded to the oxygen in that OH hydroxyl group. So if you draw it, so here's a bad example. If you draw this and you draw it like this, it will not be accepted. Okay, so that is a huge no-no. Because in this, you're showing that the hydrogen is bonded to the carbon directly and also bonded to an oxygen, indicating the hydrogen forms 2 bonds, which is not true. So the oxygen in the hydroxyl group is where you have to show your bond between it and the carbon. So when you take a look at this, we started off with a 2-carbon parent chain in the hydrocarbon ethane. We still have that 2-carbon parent chain. The carbons in the parent chain are single bonded, and they remain single bonded to each other. So what we have here, the backbone of this structure is ethane, but we placed a double bonded oxygen and a hydroxyl group on 1 carbon. So that's where we have to do our name adjustment. So we drop the E and we replace that with oic, plus we add the word acid. So this would be ethanoic acid, also what you guys would know as vinegar at home. The condensed structural formula here. So our first carbon has those 3 hydrogens attached to it. Our second carbon, it has an oxygen, and then it has a second oxygen, and the second oxygen has the hydrogen attached to it. So we always see it as COOH. There is our organic acid sequence. And I'm going to go through just going from the name to the structure. So we have hexanoic acid, and we're going to start at the same place we always do. Find the table P, prefix, hex, and hex according to table P means 6. So that means my parent chain has to be made up of 6 carbons. Lose track. I notice that it's ane, so it's an alkane, so all the carbons in that parent chain are linked together with single bonds. Now I see oic acid. I mean, hey, it's got the word acid in it, so you shouldn't be striving too hard with what to come up with. So that means that on our terminal carbon, we have to place a double bonded oxygen and an OH on our most right carbon. So I'm going to go right here, most right terminal carbon. There's my double bonded O, and here is the OH. And notice the O is the one that's being shown to be bonded to the carbon. Now that we've put everything that's in this name in the structure, we now fulfill all carbon bond needs with hydrogens. And when I get to my terminal carbon here, bond 1, 2, 3, 4. So this carbon does not need any additional hydrogens added to it. Condensed structural. Carbon 1 has 3 hydrogens. Carbons 2, 3, 4, and 5, they each have 2 hydrogens attached to them. And now carbon 6. It has its double bonded oxygen and the hydroxyl group. So I see that letter sequence to help me clue in that this is an organic acid.